Hello, everybody. This is Ryan, and we continue CCNA with quality of service. Quality of service is a mechanism to deal with congestion. And the typical way for dealing with congestion, especially on a local area network, is just to increase capacity. So if, you know, gigabit Ethernet isn't doing it, then you get a 10 gigabit Ethernet connection. 10 gigabit Ethernet connection, maybe it's still not doing it, then maybe you get an Ether channel with a bunch of 10 gigabit Ethernet connections. There's a lot that you can do on a local area network with which won't cost a lot of money. Um, when you're talking about being a service provider, or in the instance where you're talking about security, where someone is causing congestion on your network and maliciously, and you want to have a little bit of spare bandwidth to be able to send control traffic, or maybe to be able to um, log into devices so that you can uh, fix the denial of service attack. And QoS can do that. So it's not mentioned in this chapter, but QoS is it's a security issue as well. Jitter is talked about in this chapter, and just think about it in the normal definition of the word jitter, something that's shaking back and forth. You drink too much coffee, you get jittery, and that's going to serve you well. The concept there is generally applied to voice traffic, since a voice stream is a very consistent stream of data that doesn't take up a lot of bandwidth. The way that service providers used to deal with that is you would have a dedicated connection. You'd have a circuit. So remember the old, maybe you don't, the old telephone operators who would physically connect a circuit with their hands. Well, there were switches that would do the same thing. But now we've packetized everything. And those once dedicated connections where you could very reliably send your small flow of data across aren't there anymore. And to make up for that, we like to put voice in, it's high priority queue, or with, or the priority queue in low latency queuing, which also sets apart the voice traffic from everything else. So a lot of QoS is just setting the voice traffic apart from everything else to make sure that it can have that smooth, low bandwidth connection. Also, QoS is something that you're probably not going to do on your own, because in order for it to work, it has to be throughout a network, which inevitably means crossing responsibilities or whatever boundaries of responsibility there might be. That includes if you've got a service provider providing you with some sort of quality of service. For the most part, they're looking at diff serve in this, which means that you mark packets with a certain priority, and then you program all of the routers in the path, or the routers and the switches in the path, to recognize that marking. Int serve is something that I've only heard associated with MPLS, and I've never done anything with that. Great. And then one last reminder, 802.1q is the protocol that we use for VLANs. It's the same one. So you already know it, but they don't refer to it as a VLAN in this particular chapter. So it's just a certain field in the VLAN header that we use for transporting packets across a layer 2 trunk. And it's just one more aspect of VLANs. So that's it, the overview. And just to remind you guys again, this QoS is for congestion. And since malicious people can cause congestion maliciously, it can also be seen as a security measure.